Hi, this is John Isles and welcome to Geometer's Paradise. Today we're looking at Unit 4, Lesson 2, Midpoints. We have 4 tasks today to talk about. The first is calculating midpoints on a number line, and related to that, calculating midpoints on the coordinate plane. We also want to be able to use the midpoint to calculate an endpoint on a number line, and to be able to use the midpoint to calculate an endpoint on the coordinate plane. Alright, suppose we have a mountain like we did in the distance formula problems. And at the top of the mountain is your sign that says not the world's tallest mountain, just like it did before. 7 miles up. Now when we start our hike, we decide, hey, we're going to plan ahead this time. Last time we got hungry. We're going to plan ahead this time and we're going to stop about halfway. Alright, so what do? How do we figure out how far that is? Well, we divide by 2. So at about 3.5 miles, we're going to be about halfway up the mountain. But one thing you don't think about is that we're starting at 0 miles. So we could expand this idea just a little bit and say that, hey, I'm actually going halfway between 0 and 7. And to figure out what's halfway between two numbers, we actually want to add those numbers up and divide by 2. This is called a mean. A mean is one of 3 types of basic central tendencies that you learn clear back in middle school: mean, median, and mode. We're taking the mean of 2 values, so we add the 2 values and then divide by the number of values, which is 2. And this gets us 7 divided by 2, which is 3.5. Exactly the same problem that we had over here, but now we have this idea that we're adding 2 numbers together. We're taking a mean, and a mean tells us what the middle value is between 2 points. Alright, suppose we have 3 people, and 2 of them are standing on the numbers 8 and 17. So here's the first player. Ooh, he's got a very big head. And here's the second player. And the game we're playing is called Monkey in the Middle. And that's where you have a third player who plays in the middle, and the 2 players on the end are trying to throw a ball back and forth over the head or around the person in the middle. Alright, so this person is going to, we want to know where they have to stand. This person's on the number 8, this person's on the number 17. To figure out where they're going to stand, we're going to take those 2 values, 8 plus 17, and we're going to find the mean of those 2 values. Alright, well 8 plus 17 is 25. Sorry, ink pen is acting up. Imagine that. Alright, 8 plus 17 is 25 divided by 2. That's 12.5. So the monkey stands at 12.5. Okay. So the formula for midpoints on a number line is the midpoint m is equal to a plus b divided by 2. We have 2 key ideas to this problem. The first is that it's an addition problem. Always addition. This is in contrast to distance, which we learned about yesterday, which is a subtraction problem. Okay, distance is a subtraction problem, while midpoints are addition problems. Midpoints are mean values. It's the average, the sum of 2 values divided by 2. Alright, let's get some practice in. We want to find the midpoint between A and C. Well, the value A is at -2. And we're going to add that to the value of C, which is 3. So -2 plus 3 is 1 over 2. So 1/2, or 0.5, is the midpoint between A and C. Now that makes sense. Here's -2, here's 3. 0.5 is going to be right here. So you look, there's 2.5 units to the left, 2.5 units to the right. Now I want the midpoint between D and B. D is -5, B is +1. Divide by 2. -5 plus 1 is -4 divided by 2 is -2. And here's -2. It's A. Alright, D is at -5, B is at 1. Look, there's 1, 2, 3 units from D to A. 1, 2, 3 units from A to B. So, of course, we're correct. It's in the middle. A, between A and F, A is -2. F is 9. So we're dividing. And this is going to be 7 divided by 2, or 3.5. Same thing, if we come up here and check 3.5, we've got 1, 2, 3, 4, 5.5 units. 1, 2, 3, 4, 5.5 units. So it checks out. A couple things we want to think about. I led all of these with subtractions. Okay, but I could just have easily had gone this way. Instead of A first, I could have gone 3 plus -2. In this case, I still think it's important for you to write plus. Yeah, I know, plus and minus is minus. But if you write it this way, you are reinforcing the addition. And that's what you want to do. You want to continue to reinforce the fact that we're adding all the time when we do midpoints. If you reinforce it every time, you're going to be less likely to make the common mistake, which is this. There's people out there that you get the distance formula and the midpoint formula all messed up, and you end up doing something like this. 3 minus a -2 over 2, which is 5 over 2, or 2.5. Remember, the correct answer is 1/2. Alright, so if this is the case, then we're suggesting that the midpoint is clear out here. Alright, well, C is right here. A is clear over here. When you give me an answer of 2.5, you're telling me that you're not paying attention to what you're doing. Because how can a midpoint be right next to one number and so far away from the other? Okay, you want to think about your answers. If you end up with something like this, it means you probably subtracted instead of adding. Okay, the other thing that might happen is maybe you'll do something like 3 plus a -2 and get 1 and forget to divide by 2. In this case, we're okay. We're really, this one would actually be really close to the midpoint, but you could still tell it's only 2 units from 3 and it's 3 units from A. And then worse yet, maybe you subtract and get +5. +5's not even between them, not even between the 2 points. Okay, giving me an answer like 5, all right, tells me that you're not paying attention to what you're doing. And the one thing that you need to get out of geometry is an awareness of when you are making mistakes. Okay, let's advance this a little bit. 10 is the midpoint. So we're still playing our monkey in the middle game. But this time we know, this time we know where the middle player is. And we have one endpoint already. But we want to figure out what the other endpoint is. We're going to go back to our midpoint formula. M equals A plus B over 2. That is a B, I swear it. Alright, but this time we don't know the endpoints. We don't know A and B, we just know A. Right? A is going to be 18. M is 10. So we go 10 equals 18 plus B over 2. And then what happens next is we're going to multiply both sides by 2. And we end up with 10 times 2, which is 20, equals 18 plus B. We subtract both sides by 18, and 20 is equal to B. So the value of this point over here or I'm sorry, 2 is equal to b, is 2. And if you think about that, 2 and 10 are 8 units apart. 10 minus 2 is 8. And 18 and 10 are 8 units apart. And that's one way to check the midpoint. You could check the midpoint using distances. We know that the midpoint is supposed to be halfway between them. So in this case it is. It's 8 units apart from either end. Okay, so let's do a little practice finding some endpoints. Okay, A is the midpoint, so that's -2, between D, -5, and what other point? So this would be -2 equals -5 plus B over 2. We multiply, we get -4 equals -5 plus B, so that other point is going to be 1. Alright, so A is the midpoint of D and 1, which happens to be B, literally. Okay, that was a coincidence though. Alright, let's try another one. How about C is the midpoint between B and what other point? Let's clear the screen so we have more room. C is the midpoint. C is 3. And then we're looking for some point P plus B's value, which is 1, over 2. So we multiply 2 times 3, we get 6 equals P plus 1. Subtracting 1 from both sides. So C, which is 3, is the midpoint between 1 and 5. Alright, the final problem, we have point E, which is 7, and C, which is 3. So E is the midpoint this time, so 7 is equal to 3 plus something, whatever that point is, over 2. Multiplying both sides by 2, 14 equals 3 plus P, and subtracting 3 from both sides, we get 11. So 7 is the midpoint between 3 and 11. Alright, we extend this to 2 dimensions, and now we have to find the midpoint for 2 different coordinate sets, an x and a y. So I start by looking at the x coordinates. I have -2 and +5. So A is at -2, -2, 1, and B is at 5, 5. So the x's are -2 plus 5 over 2, which is 1.5, 3/2. And the y's are 1 plus 5 over 2, which is 6 over 2, or 3. And then the answer is the ordered pair 1.5, 3. Remember that x always goes before y when we write the ordered pair. This would be the midpoint. If I can check my answer, 1.5 is going to be right around here, and it matches up to 3. So here's 1.5, 3. Alright, so here we have 2 points. We want to calculate the midpoint between them. The value of A, whoops, the value of A is x is 11, and the y value looks to be -4, and the B is x 5 and y also 5. Looks like I didn't change it from the last problem. Okay, so we're going to do the x's first. So the x coordinate is going to be 11 plus 5 divided by 2. That's 16 over 2, which is 8 units. Alright, so 8 units is going to be our halfway point for x. Our y is going to be -4 plus 5 over 2. That's 1/2, or 0.5. If we look, we have a point, I'll put it in red so it's a little easier to see, right here, which is 1/2 of a unit up from the axis and 8 units over from 0. So our ordered pair, our midpoint, is 8 1/2, or 8 0.5 if you prefer. Okay, now we extend this idea to calculating the endpoints. You remember how we did this before. This new time around, we're going midpoint equals. So the x midpoint is 8, and it's going to be equal to 5 plus x over 2. The y coordinate will be 3 equals 5 plus y over 2. So the x values were 5 and the y value was 5. Alright, so multiply by 2 to get 16 equals 5 plus x. Subtract x from both sides to get 11. Over here, multiply both sides by 2, get 6 equals 5 plus y. Subtract 5 from both sides and we get 1. So the value of point A will be x11, y1. And if we look at our screen, we are at 11, 1. Okay, so that's your answer. Okay, I'll leave the practice problems for class and say then have a nice time, and I'll see you tomorrow.